Okay, welcome to part 5 of Hacking the Megatouch IN 2014. Part 4, we started looking at the accessors and seeing what data they, or what memory addresses, offsets of the object these accessors were accessing. And that didn't give me as much data as I went through it. It did not give me as much data as I remember it. Maybe the IN is different than the 2014. But let's go ahead, something that when reversing C++ that will often give you a lot of insight into an object is the actual constructor itself. So let's again look for KeyManager, and we'll find the constructor. And here it is, and the code is pretty simple. This is the constructor. Again, it takes a pointer to object, space that we've already allocated, which was just over 2,000 bytes. It's a very simple code. It's got an integer here, 4-byte integer, uvar1, an integer here, uvar2, sets uvar1 and ivar2, sets this this variable ivar2 to 0. We don't know what that is yet. Sets the field that we know is software year supported to nothing, or 0. Sets region to 0. Sets what we think is status to 0. Then it does this. Do init, check init on itself. So it's actually making its own little constructor, or not. The KeyManager is the official constructor, but rather than putting the code to initialize things in the constructor itself and put that in another subroutine, which is fine. That's just a way of making your code more modular, to break it up so it looks, the flow of this code is very simple. Anyone looking at this, if you don't care about the details of what is going on in it, you can look. It says it's initializing it, it's checking it, then it's setting the status to whatever the value of check was. If that status value, that check, is 1, it's going to write key data and return. Otherwise, it's going to increment this value and keep doing that while ivar is not equal to 2. So let's actually go ahead and just label what we know. ivar1 looks to be like, it says check this, so this looks like some type of status check. So let's just name that with L, status results, or let's call that check results. Okay, and ivar, that was uvar1. ivar1, this looks like some type of counter. We're doing something while something is not true, while something is false, and then we're incrementing this, so this is a counter. Let's call it counter. Okay, so we see this loop do something. This counter equals counter plus 1, while counter is not equal to 2. So it looks like this will do this a maximum of 2 times. I don't know why it would do it 2 times, but who knows. So already we have this code is pretty simple, but what does it do? This is just basically an outline to what are for some other subroutines. So we see that it is actually setting some values to nothing, so it's initializing some values. It's going to do this init. It's going to then check probably what it initialized, and if the value is good, it's going to write key data, whatever that does. So let's just go through this this first function init and see what it is. Init is probably going to actually set up, probably zero some fields in this key. It might retrieve some data and store it in this KeyManager class. So let's go click on that. So here we go. Undefined for this call init KeyManager this. All right. And there's sets up some variables, and the first thing we do here is this 0 equals USB IO instance. So just from the other Megatouch, I know that this USB IO is just actually like kind of a handle, or it's a USB device basically. So I'm just going to call this, I'm going to rename this USB IO instance. Okay, so this is just actually running, it's setting up, it's initializing this USB IO so it can talk to the game board. Then you see the next thing it does, it says get key family code, which we just know that this is getting the family key code. Okay, so the Dallas keys have different versions or families of the key. So this is just getting that key code. So let's just name this to key family code. Okay. So anyway, so then it gets the family key code, and it compares the byte of the family key code to different values, and if it's any of these three values, which looks like 12, 8C, whatever 8C is, 140 decimal, or 16, then it's going to set is 1995 Dallas key. Okay, so it's going to set the data member in the KeyManager class that this is a Dallas 1995 key, which is the ones I know the ions use that, the forces use that. I don't think other keys can actually be used in this code, but it may be in this game, but this code may be actually being reused from other systems. Who knows? Otherwise, if it's not one of those three values, it's going to set the Dallas key to 0. Then what do we have here? And this is a common construct you'll see. There's a couple things we can see here. We can see that it's setting a variable, ivar equal to, this is a decimal 16, hex 10 or hex 10 is decimal 16. Des0 is a pointer to this field 3F0. Okay, so this is actually a pointer, and I'm gonna actually change that variable. Des0 is, we're just gonna call that a it says it's an undefined 4, so uint 32t pointer. Okay, and we're gonna change the name to temp ptr. Okay, so it's got a pointer here to this field, and then while ivar2 equals 0, it's going to do some things, and you'll notice it's actually going to decrement ivar2. So again, this is a counter. This is counter, and it's actually counting down 16 times. So I'm going to call it counter 16. So while counter 16 is not equal to 0, counter 16 equals counter 16 minus 1. Temp pointer equals 0, the value of temp pointer. So whatever this was pointing to, it's going to be 0, and we know it's a undefined 4 pointer. Means it's when it writes the value 0, it's going to actually fill in 4 bytes of zeros. Okay. Excuse me. And and then it's going to increase the pointer by 1. Okay, so that's going to actually move it 4 bytes. So all this is doing is actually 16 times it's writing 4 bytes of zeros and then moving over 4 bytes. So this is actually going to 16 times 4 is 64. This is actually code is going to, I'm going to put a comment in here. Not there. Right here. I'm going to put a comment. We're going to do it a pre-comment, a plate comment. I'm going to do write 64 bytes of 0 to field 3FO. Okay, you can see it appears there. I wish there was a good way of making it appear here on in the disassembly, but I don't think we can. Sometimes you put the code in, the comments in, and you actually can see it. I'm going to try a pre-comment. Sometimes you can't because, well, don't worry why that is. The only thing you can be assured that you're going to actually see the comments are in the disassembly listing, or the listing field, the listing window. Oops. Let's see if that will put it there. Oh, okay, so it does put it there. And so we know, what do we know about this? This field 3F0 is probably 64 bytes long. So I'm actually going to change this I'm going to hit Control L. I'm going to change the type of field 3F0 to car 64. Okay, and I'm going to change the name to 64-byte buffer. Now it doesn't necessarily mean it's 64 bytes, but I'm going to just put that there. If I learn that it's not 64 bytes, maybe it's actually, for example, we'll see it in this next code, it's actually doing the same thing 64 bytes later. It might be initializing some data in chunks. I don't know yet. But again, here we go, counter 64. This counter 16 is set to 16. And ptvar4 equals, now this is, I don't think correct. I think it got confused upon the time t pointer. I don't believe it's a time t pointer. So I'm going to actually set this field for 30. It's doing the same thing. It's writing another 64 bytes here. So I'm going to change the name to 64-byte buffer 2, and I'm going to change the type to car array of 64. Okay, and ptvar4, we're changing that to not a time t pointer. We're going to change that to a just a car array uint 32 t pointer. Now why? Oops, uint 32 t pointer. What uint 32 means it's a 4-byte integer, unsigned integer. It doesn't matter whether it's unsigned in this case or not. And we're going to just call that temp ptr2. Okay. And so you might be saying, well, why is it, if I said this is a 64-byte buffer, why is the pointer an integer pointer? Because it's optimizing. It's faster to write 4 bytes at a time 16 times, so an integer basically, an integer is 4 bytes, or a uint32, rather than writing 64 bytes. So this is an optimization the compiler made. It's just treating this 64 bytes as actually basically an array of 16 integers and setting them all to 0. That's the same as initializing 64 bytes to 0 each. So that's an optimization. And again, we're doing it again here, field 470, and you'll notice these fields were all exactly 64 bytes from each other. So we'll do that again. We're just going to mark it car 64, and we'll call it 64-byte buffer 3. And I'm actually going to rename this one 64-byte buffer 1. So we have 3. Oh, here's another one. So again, we're initializing 64 bytes to 0. Car 64. Change the name to 64-byte buffer 4. All right. Now we have another thing here. Dest is a pointer to this part number. Now this tells us a bunch of things. So because it already determined, or GHIDRA said this is undefined 4, it thinks that it's writing 4 bytes, and it's going to do that. Then it's setting a pointer. This part number dest equals 0, so then it's setting that to 0. So I'm going to go ahead and tell this part number what it is, how many bytes it is. Before we didn't know. We said it was undefined 1. I'm going to put uint 32t because it's a 4-byte thing. Okay. All right. So then dest equals 0. So this is initializing this value of the object to 0. Then it's going to do this for a whole bunch of things. And you see in each one there's different values. Undefined 4, undefined 4. Somewhere down here we have undefined 2. For each of these fields, and it makes sense because if you actually look at as it hits it, it's going to you can see that these values are like 4 apart from each other. So actually that's really interesting because this is not even on a boundary. That's I don't know how it did that. That's well, who knows. So let's go ahead and put the sizes in here. So Control L, uint 32t because it's a 4. This is a 1. Undefined is just a single byte. So we'll just mark that L as, oops, Control L, is a car, single byte. Serial number, it says it's a 4-byte integer, at least it thinks it is. I think the serial number is actually, I think it's doing this in pieces, but anyway, it doesn't matter. We're going to say Control L. Again, and some of the assumptions we make we'll find are actually wrong later, but that's okay. If you have any clues of what something is, you want to put it down there. You can always change it later. And again, if you're not sure, or some level of unsurety, you can put question marks to say, hey, I'm not really sure about this, or write comments. So I'm pretty sure the serial number is actually this is just the beginning of a character string. But since it's defining it as undefined 4 right here, I'm going to just tell it it's a uint 60. I'm sorry, uint 4. I'm certain that it's actually that's not correct, but we'll change it later when we find out for sure. Okay, undefined 4 again. I'm going to do that again. Uint 32t. Okay, and here we see it does something a little different. It does a memset, the address of server URL, the value 0, and C9. So we know C9 is decimal 201 bytes. Now I love when they do things like this, because this tells me exactly how big that field is. Some of these, as I mentioned, we're going to find that they're wrong. That it was just an optimization. It may be setting a bunch of different field, or maybe setting one field in multiple steps, so it shows up as different fields when there's actually one. But here it just does 201 bytes to this address. We know the value. This server URL is a car 201. Okay. Same thing with web port URL. 0x65 is 101. So I'm going to change that to car 101. And here we do memset field whatever 300. So whatever this field is, I'm going to name the name. I'm just going to call it buffer 300. And we'll change that value to a car 300. So we know these fields are that's almost certainly these lengths are going to be exactly that. Okay, we set the checksum to 0. You're supported to 0, which is interesting because we already did this in the KeyManager. I don't know why it's doing it again, but it's just redundant code. Software you're supported, region, and then we get to read this, and that's going to be important. So up to now we can see that all this thing is doing, this init function, is it's accessing the USB device, basically getting a handle to that USB device, reading the USB device, the USB I/O board in the Megatouch unit, getting the family code of the key that's inserted, and then based on what code, family code it is, it's setting a field. Is this a Dallas key or not a Dallas key, or not a 1995 Dallas key, as opposed to a different, like a 1993 Dallas key. And then all it's doing so far is it's just writing zeros. It's initializing, emptying, or not emptying, but it's initializing the data in the class to 0. I think we're going to find when we go and look at this read function, which we'll do in the next episode, that I think we're going to do this in the next episode, that it's actually going to now start to fill in those values, probably with the actual key data. Okay, so well, that's good. This is about 25 minutes long, so we'll cut it off now, and I'll see you in the next episode.